To do any kind of work, you need some capacity to do that work. So that will be called as energy. In the previous one, P external was greater than P internal, but here P external and P internal are in the equal mechanical equilibrium. By the difference of integral values, we can find out how much internal energy could be present, but not accurately. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College, Temple of Excellence. Today, we are starting up session 2 from the chapter Thermodynamics. In the last class, we have discussed about the introduction part of thermodynamics, limitations of thermodynamics, terminologies which will be used in the thermodynamics, and reversible and irreversible processes with the different kinds of other processes also like adiabatic, isochoric, isobaric and etc. In this class, we will discuss about types of work, heat and internal energy. How work will be distributed with respect to energy in other kinds of work. We will see now. Work, heat and energy. The fundamental physical property in the thermodynamics is work. Work is one mode of energy transfer between the system and the surrounding. We know that this is system, this is surrounding, this is system, this is surrounding. The fundamental physical property means in the physical properties of, in the physical chemistry, work done is the most fundamental thing. So, a work is the one mode of energy transfer between system and surrounding. Work is said to be done when an object is moved against an opposite force. Means if the force is moving in this direction, that work will be done in the opposite direction. Correct? Here the force has been started. Here work will be done in the opposite of force. Work is done when point of application of force is displaced in the direction of force. When the application of force is displaced in the direction of force, here the formula force into displacement. Energy of a system is its capacity to do work. To do work, you need some amount of energy. So, energy will be called as capacity to do work. Energy is fundamental thermodynamic property. There are a limited number of ways in which energy may be exchanged in the form of work. To do any kind of work, you need some capacity to do that work. So, that will be called as energy. And it is a fundamental thermodynamic property like work. And there are limited number of ways which can be, energy will be exchanged in the form of work. Types of work that thermodynamics is concerned with are as follows, that is mechanical or gravitational force or work. See here, first we will see mechanical. The most commonly employed method is pressure volume work. This PV work means pressure and volume will be employed in this work. The work performed when the system changes its volume under the influence of an external pressure is pressure volume work. When the system changes its volume, with inside the system it will be changes its volume under the influence of external pressure is pressure volume work. Let us consider a cylinder fitted with a frictionless piston filled with gas. External pressure, the piston moves out, thereby the gas gets expanded. Means this is filled with gas, this is a piston, this is internal energy, this is internal pressure, this is external pressure. What they are telling, if the internal pressure is more than the external pressure, this gas will get expand, this piston will move out. The gas inside the piston does not work on the surrounding, hence energy of the system decreases. On the other hand, if the external gas is higher than the internal pressure, the piston moves inward compressing the gas. In the other case, external pressure is more, this internal pressure is less or decreased means the surrounding will move the piston inside, this gas will be compressed. These are the two cases when the external pressure will be higher than the internal pressure one side, and another way or another case is external pressure will be less and the internal pressure will be more. The work is done on the system. In this case, the energy of the system increases if the energy does not flow out of the system. See here, work done on the system means the internal energy is less. Work done by the system means internal energy is more. This work done by the system on the system is very much important to understand the overall thermodynamics. Next, electrical work. This is the another kind of work. In case of electrical work, the force is EMF and displacement is the quantity of electricity flowing through the circuit. To understand about the electrical work, this EMF, that is electromotive force, and the displacement is the quantity electricity flowing through the circuit. If the EMF of a reversible cell, that is E volts, and the process taking place is associated with the passage of N Faradays of electricity, that is N number of Faraday coulombs, that electrical work done by the system will be NFE. If the EMF of a reversible cell, means they are using a reversible cell which is having a number of E volts, and the process taking place in the associated with the number of Faradays, its value is coulombs, and the electrical work done by the system will be NFVE, that is volts per coulomb or joules. See here, W electrical equal to minus NFE. By the system will be minus sign, on the system will be having positive sign. Next, gravitation work. If an object is moved through a certain height against the force of gravity, certain height against the force of gravity, work is done and it is said to be gravitational work. We know that any object will be thrown means it will be come back to the ground because of the gravitational force. That's what they are telling. If an object is moved through a certain height against the force of gravity, work is done and is said to be gravitational work. It is numerically equal to mgh, mass into acceleration due to gravity and height moved. This is the gravitational work formula. mgh, mass of the object, g, acceleration due to gravity, h is height moved. Here mg is the intensity factor and h is the capacity factor. Exothermic process is one in which heat flows out of the system. Heat is evolved from the system, Q equal to negative for exothermic process. If there is a system, heat will be evolved out of the system, that is negative value. If the endothermic process is on which heat flows into the system, the energy of system increases, the endothermic process will be Q positive. If the heat will be taken into the system means positive, taken out of this system is negative. This is exothermic. Exo means outside, endo means inside. The heat, therm means heat, exothermic means heat will be evolved from the system. That's why exothermic. Into the system, the heat will be developed into the system is endothermic system. Among the two modes of transfer, while work makes use of ordered motion in the surroundings, the heat makes the chaotic motion, that is thermal motion. The SI unit of work and heat is joule. See, this is energy conversion factor, R equal to 0.082 liter atmospheric per mole per Kelvin. So 1 liter of atmospheric pressure, for it will be constant R, 24.2 calories. And next 1 liter, that is 8.314 by 0.0821 joules, and this is 1.018 into 10 to the power of 9, and here the overall, the constant 8.314 into 10 to the power of minus 3 kilojoule per Kelvin per mole. Next one, heat. Heat transfer is another mode of transfer of energy. If the heat is liberating or heat is generated or moving heat, will be called as a transfer of energy, is nothing but a kind of energy. This transfer occurs due to the difference in temperature between the system and the surrounding. How can we relate with the system and surrounding? If the temperature is getting to change within the system or in the surrounding, obviously the heat will be generated or liberated can be seen. It is represented by Q. It is a path dependent quantity. Among the two modes of transfer, while work makes use of ordered motion in the surroundings, the heat makes the chaotic motion. The SI unit for work and heat is also joules. For this one also, joules only the SI unit. Next, general expression for mechanical work done. How the mechanical work done will be, for that how the general expression will be seen. What they are telling, consider a cylinder fitted with a piston of area cross section A. The volume of the ideal gas of the cylinder is V initial. Let the external pressure acting on the piston be P external, which is slightly greater than the pressure of the gas. The gas gets compressed and piston moves inward through small distance dl. By definition, work done on the gas is given by dW FdL, where F is the force acting on the gas. See here, this is a cylinder fitted with a piston. What they are telling, it is having a cross section A. The volume of the ideal gas is V initial and the external pressure acting on the piston will be slightly greater. This will be slightly greater than this one. What will happen? It will be, if external pressure is more than the internal pressure, what will happen? This piston move inside and the gas will be compressed. The moving distance will be by dl and the force exerted will be F. So, dW, that is work done, equal to FdL, force into distance. See here, it will be pressure or into cross section. How it will be? PdL into A. This is the equation first. Since dl into A, the small change in volume of the gas means the small changes will be there in the volume because it will be compressed. V initial minus V final. What will happen? dW equal to P into V initial into V final equal to minus P V final in minus V initial, that is minus P dV. Means it will be work done in the system, that is on the system is there, no? That's why it will be minus. To find the total work done when the volume of a gas changes from V1 to V2, we integrate the equation, the second equation between the initial and final volumes. See here, V2 minus V1 minus P dV equal to, how the integration has been taken, P minus P has taken out. This is dV equal to minus P V2 by V1. This is V2 by V1 will be subtracted. The difference will be written as del and minus P delta into V. Both for expansion and compression, W equal to minus P external delta V will be used. The sign of delta V in each case takes care of the sign of W. The expression gives that work done in a single step process, that is thermodynamically irreversible process. Here the sign of delta V and W can be taken care of. Next, expression for work done during reversible isothermal expansion. The pressure of the gas P is set equal to the external pressure P external. Okay. The pressure of the gas will be equal to P external. The system is in a state of mechanical equilibrium. In the previous one, P external was greater than P internal, but here P external and P internal are in the equal mechanical equilibrium. If the external pressure is reduced infinitesimally, the gas expands slightly. The change is thermodynamically reversible. At each stage of expansion, P external is set to equal to P. The general expression is. If the external pressure is little bit reduced, what will happen? The internal pressure will increase and the volume of the gas will little bit increase also. See here, V2 by V1 P dV. The expansion occurs under isothermal condition. The equation of the state for an ideal gas is PV, that is nRT or P equal to nRT by V. This is ideal gas constant. We know that is. In an isothermal process, T is an maintained constant and V is the volume at the stage of expansion. T will be the every time same, that is temperature. V will be the little bit changes can be seen. That nRT has been substituted here. nRT by V into dV. Since n, r and t are constant, they can be taken out of the integrals. These are all constant. N is constant, r is constant, that r is nothing but gas constant, t is temperature, all are constant, taken out, and whatever the without variables are dV by V minus nRT ln V2 by V1. If you want to convert into log, work done W equal to minus 2.303 nRT log V2 by V1. This is the formula for work done. See here, V2 by V1 equal to P1 by P2. At constant T and N we have minus 2.303 nRT log P1 by P2. This is the magnitude of maximum work done in an isothermal expansion of gas. Next, free expansion. Expansion of a gas in vacuum, that is P external equal to 0, is called free expansion. Means the external will be 0, pressure external. No work is done during free expansion of an ideal gas, whether the process is reversible or irreversible. In the free expansion, external pressure will be 0. Obviously, work done is 0 during free expansion. Whatever the condition, that process may be reversible or irreversible. Next, internal energy. In the thermodynamics, the total energy of the system is called its internal or intrinsic energy. The total energy of the system. If the sum of translational, vibrational, rotational and electronic energy, bond energy, nuclear energy and the energy due to interactions in a system will be considered as internal energy. While the molecules in the system get translational, rotational, vibrational, bond-to-bond energy and nuclear energy can also be created. Energy due to interactions in the system will be called as internal energy. Within the system, it is denoted by U and is measured in joules or calories. Internal energy is a state function and extensive property. It is not an intensive property, it is an extensive property. The absolute value of internal energy cannot be calculated. The absolute value cannot be calculated, which is in the system. However, the change in integral energy of a system in a process can be determined precisely. But the changes can be seen on the system or by the system. By the difference of integral values, we can find out how much internal energy could be present, but not accurately. The change in internal energy can be brought about by the work or heat. Whatever the changes could be seen on the system or by the system, which will be done by heat or work. If it is no heat or if it is no work is given to the system, no difference of integrals can be seen. If U1 is less than U2, then delta U is positive. If U1 is greater than U2, then delta U is negative for the process. Heat and work are the two distinct modes of internal energy change of a system. The internal energy of a change can be increased in two ways. By doing work on the system, by pushing the piston over the gas filled in cylinder, by heating the system. How it can done? By doing work on the system or by heating the system. Next, characteristics of internal energy. Internal energy of a system is an extensive property, we know that, and it is a state function. The change in the internal energy does not depend on the path which the final state is reached. It is not a path dependent. It is not possible to measure the absolute value of U, only it can be measured in precise way. The internal energy of an isolated system is constant. There is no change in internal energy in a cyclic process. In the cyclic process, the internal energy will be not changed. In cyclic process, the internal energy of a system assumes its original magnitude. If all the internal energy changes in different stages of the cyclic process can be summed up, this would be equal to 0. Whatever you have initiated the process, and all the stages if you summed up, it will be equal to 0. That's why no change in the internal energy. These are the characteristics of internal energy. And whatever we have seen the process, while see the thermodynamic sign convention, heat absorbed by the system means it will be positive, that is endothermic. Heat released or evolved by the system, that is negative exothermic. Work done on the system positive, by the system negative, energy released by the system negative, energy absorbed by the system positive. This is internal energy of the system decreases, internal energy of the system increases. Whenever the internal system will be getting heat or getting used by the surrounding, that time it will be positive. Work done by the system exothermic or the heat released by the system will be negative. These are the thermodynamic sign conventions. After studying all the concepts, heat, work, energy, everything, you should aware of these sign conventions because it will be used in the numericals part. So in the next class, we will discuss about first law of thermodynamics and enthalpy. I hope you have understood completely what I have done today. We'll meet in the next session. Thank you.